We are titling these notes at 4.4c. The second FTC. Draw this graph. While you're drawing this graph, I have decided instead of having a Friday, Monday test, we'll have a Monday, Tuesday test. Okay.
No, I'm like, I don't know.
Well,
I don't know what.
here, I just,
It's good, but like, both. I don't know.
both kind of stink.
Yeah,
Yep. I'm with you, Isaac.
that's how the world works. So.
Scratch the test computer.
You know, the Sunday test. Jimmy Monday, Tuesday, but we don't do good tests. We just like watch it.
What's that one movie about that lady who was in the NASA?
Hidden Figures.
So that's about math.
That one lady-
I like that.
Yes.
Okay, I also need you to write down that g of x is the integral from 0 to x of f of t dt. Oh, interesting. Okay, so we call this an accumulation function because it's written as an integral, the accumulation of area under the curve. And we're going to find g of 1, g prime of 1, and g double prime of 1. I can. All right, so let's find g of 1. Well, g of 1 means I want the integral from 0 to 1 of f of t dt. Okay, well, here is graph f. And so g of 1 is asking us to find the area under the curve from 0 to 1 for our graph f. So from 0 to 1, what's our area? Three halves. Okay. Now, let's talk about g prime of 1. Okay. Well, let's come up here. If I take the derivative of g, what is that going to be? f of x. Oh my goodness. Guys, this graph of f is the derivative of g. So this is g's derivative graph. Oh. This is g prime. F is g prime. F is g prime. So if I ask you for the derivative at 1, looking at my derivative graph, what's the value? Ooh. At x equals 1, we have a critical point. More on that soon. It's all coming together. Let's talk about the second derivative. Oh man, did you use the last one? You just almost threw them away. Well, if the first derivative of g is f of x, then the second derivative of g is going to be f prime. Okay. So if I'm asking you for the second derivative at 1, I want the first derivative of f. And if this is the graph of f, what characteristic should we look for on this graph? What did you say? We need to look for the slope. I agree that this is the maximum, but if I'm looking for the second derivative and our second derivative is f prime, then if this is the graph of f, f prime is the slope. So what is our slope of 1 at 1? 3. Are we okay with why we identified the slope? Thank you for your smile. Kind of a fake smile, but I appreciate it nonetheless. Okay. Now, let's talk about where g of x is increasing and decreasing. This is good stuff. If I want to know where g of x is increasing and decreasing, then I want to know where our derivative is positive and negative. We decided that this graph of f is the derivative graph for g. So where is our derivative graph positive? From -1 to 1. And so that's where function g would be increasing. Okay. From -2 to -1 and from 1 to 2, our derivative graph is negative. Therefore, our function would be decreasing. Oh man, unit 3 coming back for us. All right. Specifically, Kylie, what's happening at x is 1? There's a maximum. Specifically, Isaac, what's happening at -1? Minimum, because our derivative goes from negative to positive. Over here, a maximum, because our derivative goes from positive to negative. Yep. Remember those? Only sort of. Okay. Now let's talk about concave up and concave down. Okay. What characteristic, yikes, what characteristic about our derivative graph do we look at in order to determine where we have concave up versus concave down intervals? You know? What do we look at? Yeah. Okay, where our derivative is increasing, our second derivative is positive. Aaron, where does that happen here?
-2 to 0.
Okay, so we would be concave up from -2 to 0. Okay, from 0 to 2, our derivative is decreasing. Therefore, our function is concave down. When old stuff comes back with the new stuff. Yeah. Okay, same graph. Same graph, same function. So yesterday somebody wrote "you are sus" on my board. And so as a 5th hour, we decided to fill it in with a different word. It is a word.
What is it?
What does it mean? No.
I really hope like.
I like
it
this.
means
Full
so-
of whispering sounds.
Full of whispering sounds.
I love
Exactly. If only you all could see that. Okay. Let's see. Okay. G of -1. Okay. Earlier we found G of 1. Now I'm asking for G of -1. Now, if I'm asking you for G of -1, and this is my function G, I'm asking you for the integral from 0 to -1 of f of t dt. Ooh, boy. What is true about my limits of integration? 0 to -1. They're going backwards. So here's the area from 0 to -1. It's above the x-axis, but we're going from 0 to -1. That's going to the left. So this is going to be also, or not also, this is going to be -3/2. If we're going to the left, we have to negate whatever area we find. Okay. I also want to calculate G prime of -1. G prime of -1. Think about it. Look at the graph. Think about it. Nathan, what's G prime of -1? No, no. Remember, F is the same thing as G prime. So this is the graph of our derivative. So on our derivative graph, what is the y value at -1? Ah, G prime of -1 is 0. Yeah. Okay. Specifically, -1 is graph G minimum, like we talked about before. Okay, I am going to hand out a worksheet that's only front-sided, and you and your pod are going to work together to answer the questions. This is what it's going to look like. First of all, you're going to get 2 graphs, and for each, you're going to identify from least to greatest, the integral from 0 to 1, 0 to 2, 0 to 3. Then you're going to say, all right, G of X is our accumulation function. Where is G increasing, decreasing, etc. Okay. Then number 2, you're going to find me, oops, I did it twice. You're going to find me for this graph. Here's our accumulation function. You're going to answer these questions. Okay. So I'm going to give you about 10 minutes to do this together, and then we're going to talk about it as a class. All right, here we go. For graph number 1, I'll highlight it here in yellow. If we were to list the area from 0 to 1, 0 to 2, 0 to 3, from least to greatest, Nathan, what would that be?
X equals 3. X equals 1.
Okay. The area from 0 to 1 is positive, but then when we go from 0 to 2, we add some negative, and then from 0 to 3, we add a little bit more negative. Okay. If G of X is our accumulation function, then that makes this the derivative graph. So because of that, then our original function G, Austin, would be increasing where? Awesome. And then our original function would be decreasing where, Aaron?
It's decreasing from 1 to 3.
Good. All right, now let's talk about this guy right here. If we plug 1, 2, and 3 in, so basically the area from 0 to 1, the area from 0 to 2, the area from 0 to 3. Okay, Connor, how did you all organize those from least to greatest? Were you a little bit confused about which one to put first, 3 or 1? Did you feel like they could have been the same? Okay, if you have 1, 3, 2 or 3, 1, 2, I would accept either one of those because it does appear, well, I mean, yeah, it looks like those are going to be canceling each other out, right? Okay. So if this is our function here, whoops, if this is our function here, then this is considered the graph of G prime. So where is original G increasing? Dylan, what did you say? Okay, and our function G is decreasing, where, Carolyn? Awesome. Okay. Now let's go to number 2. Okay. Here is our function, which means this guy right here is big F prime. Okay. On what intervals is big F increasing? What would you say? What characteristic are we looking for in this graph for F, big F, to be increasing? Mhm.
So.
Okay, and so our reason why, Kylie, what would we write? Okay, little f is positive. Okay, good. Where does f of x have a maximum? Isaac, where's our maximum? Oh, why is our maximum at x equals 1? I'm gonna kind of have to squish these in here. So, okay, so little f goes from positive to negative. Awesome. Big F of 4. Big F of 4. Wyatt, positive, negative, 0. He said negative. Quinn, why would that be negative?
Most of it's negative. That's why.
Okay. All of it's negative, right? Because we start at 1, so all of our areas under the curve. Okay. How about f of negative 2? Corinne, what did you say about that? And why did you say it was positive? From 1 to negative 2. That seems a little backwards to me. Negative 2 to 1 would be positive, but notice how 1 has to stay right here. So what's going to be true about 1 to negative 2? This is actually negative because we have area above the x-axis, but we're going backwards. Okay. All right. And then what about f of 2? Let's see. Tiernan, what's true about big F of 2? Positive, negative, or zero? Why? Why? Okay, we have area under the x-axis. Okay. Okay, so don't forget, if you go to the left, you have to make it everything opposite. Okay, so I have a worksheet for your homework tonight. Woo, another worksheet. Okay, the graph is what I call the detective hatch. So I call this guy the detective hatch function. And I have questions you need to answer about the detective hatch.